I know most of you started exams, and algebra is a massive part of especially these June exams, so we need to hopefully be comfortable with this. So I'm going to make quite a few notes on this first example because these are all things you need to remember as we head into algebra with exponents. All right, so what we're looking at today, grade 8 in my English, is the idea of distribution when simplifying algebraic expressions. So very importantly, distribution often involves brackets, and the operation that we're using is multiplication. So it's very important that we know that when we see these brackets and we need to perform an operation, that operation is multiplication. The next thing that's very important for you to know is how many terms it is that you are working with in your expression. So just as a reminder, terms are like the parts or the things that make up an expression, and they are separated by plus or minus signs. I know some of you can't see the screen. I just want to finish my sentence and I'll reshare again. So they're separated by plus or minus signs, and importantly, we only look at the plus or minus signs outside of the bracket. If it's inside the bracket, we can ignore it. That is then its own separate expression going on. We don't need to stress about that. So terms are separated by plus or minus signs outside of the brackets. Right, I'm just stopping my screen share for a second. Hopefully now everyone will be able to see. If you can't see, you need to log out and log back in again. I'll tell you when it should be up. Right, you should be all be able to see it. So guys, if we go to our expression that I've given you here, and we take into account this idea of terms, we are ignoring the signs inside the bracket. And so the only plus or minus sign I have in this expression is the minus between the brackets. What that's telling me is that this expression has got two terms to it. Here's my first term of 4 times the bracket 2x minus 1. And here is my second term of the minus 1 times x minus 1. Now, very importantly, especially in terms of the second term over here, what we need to remember is that whenever there is a sign in front of the bracket, so here we've just got a minus sign in front of the bracket, we actually have that invisible coefficient of 1. We just don't write it in. Now, that's going to be very important when we start to distribute. So according to my expression that I've been given, I now need to distribute. So I now need to multiply the number in front of my bracket, so the coefficient of the bracket, with each term inside the bracket. So the 4 will be multiplied to the 2x and to the negative 1. And the negative 1 in the second term will be multiplied to the x and to the negative 1. So when distributing, we are multiplying values. Right, you don't need to have the separate little block. I'm just going to draw one because it is quite helpful, especially if we get a bit overwhelmed with the multiplication stuff going on. So if we just have a look at our first set of multiplication, so at my first term is telling me to take 4 times positive 2x and 4 times negative 1. So if I look at my first multiplication, a positive times a positive is a positive. 4 times 2 is 8, and then we have that variable x. It's not being multiplied with anything, it's just 8 times x, which is 8x. Then I've got 4 times negative 1. Positive times a negative is a negative. 4 times 1 is 4. So from my first term's multiplication, I'm getting 8x minus 1. Then if I move on to my second term's distribution, I have got negative 1 times x. You don't have to put the brackets in if you don't want to. I like to use brackets, especially when I'm multiplying with negatives, because it makes me very aware of the signs. So a negative times a positive for the first multiplication is a negative, and 1 times x is then x. So I've got negative x. A negative times a negative is a positive. 1 times 1 is 1. So I've got plus 1. So from the distribution in my second term, I've got minus x plus 1. Now, guys, the next thing that we always want to check for ourselves is, do I have like terms? So once we have distributed, we want to check for like terms. It's going to take me a second. So while I'm writing this down in the chat, can someone tell me what a like term is? So in the chat, tell me what like terms are. So guys, on the chat, what are like terms? Good, I'm liking what I'm seeing so far. I'm very glad we listened to our lesson on Wednesday, guys. Well done. Keep it coming, let's see. Good. Right, so guys, very importantly, a like term is a term that has the same variable, and we mentioned this in the last lesson, and the same exponent. So as we start to deal more and more with exponents, that's going to be very important. For now, though, we can see that we've got like terms of 8x and minus x. Remember, of course, that in front of that x, there is actually that invisible 1. We just don't have to write it in. And then we have our constant terms of, excuse me, positive 1 and negative 1. It would also really help if I wrote down the correct value here. It should have been 8x minus 4. Right, there we go. So we've got our constant like terms of negative 4 and positive 1. Remember, as I've said to you before, if you would like to rearrange this so that it's in an order you're more comfortable with, so putting the like terms together, that is absolutely fine. You don't have to, but you can. And what you can now do is you can go and simplify. So 8x minus 1x is 7x, excuse me, minus 4 plus 1 is minus 3. We always double check to see if we do have like terms, but in this case, I don't have any like terms here. And so this is my final answer. So just a reminder, if the terms you're working with are not like terms, you cannot add or subtract them. And because 7x and minus 3 are not like terms, that is where we stop. Our expression is now simplified. All right, so take a screenshot of this whole beautiful screen. If you have questions, now's the time to raise your hand. Some people are still struggling to see the screen and hear. If you can't hear, then my talking to you right now is irrelevant. But if you can't see the screen, once everyone's taken a screenshot, I will reshare my screen, but otherwise you need to log out and log back in again. Ooh. I'm just giving everyone a chance to screenshot, and then I will reshare. Hopefully that will help some of you who are still struggling to see the screen. Naledi, I'm not too sure what you mean. You can maybe raise your hand to try and explain it to me. If you're talking about how is it all of a sudden positive 1, that's because a negative times a negative is a positive. But I'm not too sure what exactly you are referring to. So you can raise your hand and you can help me. Camera, yes, whenever you have an expression, you always need to double check if you have any like terms that you can add or subtract. Right, let's have a look at another one. So now, guys, we need to bear in mind what happens when we start multiplying with variables. And this is going to take us back to our exponent laws. And if you don't remember your exponent laws, we have done exponents already at Watobe, so you need to go and watch the videos. Alrighty. So first things first is what we see is that we've got no plus or minus signs outside the bracket. And so what that means is that you actually only have one term here. That's quite helpful to know because now I know that when I distribute, I'm multiplying the 4x with the negative x, positive x squared, and the 4x with the negative 2y. So that's the only distribution I need to do here. So again, I'm just going to draw a little multiplication block for myself to help me out with my working out. And the first product I need to find is 4x times x squared. And then I need to find the product of 4x times negative 2y. So let's start with the first one. And the first thing that we need to remember when we are finding this product is our exponent laws. So our exponent laws tell us that when we have the same bases and we are multiplying them together, so same bases would be x and x, what our law or first law of exponents tells us to do is when we multiply with the same bases, we add the exponents. And so this would give me x to the power 5. Now that's going to be very important for me to remember because I've got the same bases here. I've got x and x. And so when I go and multiply them together, I'm going to have to add those exponents. So let's do this product. A positive times a positive is a positive. Remember, of course, the x squared does have a 1 in front of it. So 4 times 1 is 4. And now we need to apply our exponent law to x times x squared. X has an exponent of 1. X squared has an exponent of 2. So when I go and add those exponents together to get my product, I get x cubed. So x times x squared is x cubed. So my first product is 4x cubed. Now I move on to my second product. 4x times negative 2y. A positive times a negative is a negative. 4 times 2 is 8. And then we've got two different variables here. We've got x and y. I can't really do anything with that, so it just becomes negative 8xy. So that is my second product that I need to write down, minus 8xy. Now again, what you need to notice is these are not like terms. So therefore, you cannot add or subtract them. So we cannot simplify further. And so this answer, 4x cubed minus 8xy, is the final simplified answer for this expression. So very importantly, grade 8, when you are multiplying variables, you need to remember your exponent law. And I've written that exponent law very, very briefly in the pink bubble there. We have also done exponents, so please remember to go and watch those videos if you don't remember or you're feeling confused. Okay, we're now sort of bringing all of our knowledge together. So take your screenshots. I'm going to wait for you to do that. Whilst you're doing that, if anyone has any questions, now is the time to raise your hand and ask me. Otherwise, we're going to move on to another example. Okay, so again, guys, as we start to move up in algebra, we're going to start to combine a lot of the knowledge that we have taken from the basics, from exponents, etc., etc. And so we need to be able to combine everything that we know. Lubanzi, the color options aren't there anymore, but let me just, hopefully that helps. They shouldn't be there anymore. Okay, so Tohira, the pink exponents, that was just my example. That was me explaining the law. Because I had x squared times x cubed, the law tells me that I add the exponents when I multiply with the same bases. So x squared times x cubed would mean I would need to add those exponents, 2 plus 3, and so I would get a product of x to the power 5. So that is what my law is telling me. That was just an example of my exponent law. Bunzi, I hope that's helped. Me just making it a bit smaller, but weird that it had the color option still. Yes, camera, we need to try and follow this method. There's actually only one way to do it in this case. So yeah, we need to try and follow this method. You don't have to draw the multiplication block if you don't want to. I just do that to help explain where our products are coming from. Right, guys, let's have a look at another one. Okay, so this is a little bit more complicated, but not more complicated than anything else. We just have to be able to apply our rule. So firstly, let's just check what we're working with. We can see that we only have one term here. And so what that means is that this negative 2xy squared has to be distributed to the minus 3x, the minus 6y, and the positive 4x. Now, again, we've got a fair amount going on here. So I'm just going to do a little block for my working out for myself. My first product is minus 2xy squared times minus 3x. Now, guys, break this down. Don't try and do everything at once, especially if you're not super comfortable with exponents and products. There is no need to try and rush it. There's no need to try and do everything at once. Just go step by step. And if you need, remember our SNV. If you don't know what SNV is, signs, numbers, variables. Do it in that order and you should be okay. So if we follow SNV, the first thing that we deal with is our signs. So a negative times a negative is a positive. So I've dealt with my signs here. Now I move on to the numbers. 2 times 3 is therefore positive 6. And then I go on to my variables. Now what we need to be careful of here is that I've got two different variables. I've got x variables, and then I also have the y variable, that y squared. Now remember, my exponent rule of multiplication and adding exponents only applies with the same bases. So now when I say x times x, I can apply my law and add the exponents, both of them having an exponent of 1. And so x times x gives me 6x squared. Now the y squared, there is no other y variable that I'm multiplying with. So it just stays exactly as it is, y squared. It's not been multiplied by another y or another y squared or a y cubed or anything else. It just stays y squared. So my first product here is going to be positive 6x squared y squared. Then I need to have a look at my second product. So my second product that I'm working with is the minus 2xy squared times minus 6y. So we do the same thing, signs, numbers, variables. Negative times a negative is a positive. 2 times 6 is 12. Now, again, I've only got one little x variable here. It's not being multiplied by anything, so it just stays x, but I've got a y squared times a y. This is where my rule comes in. If I'm multiplying with the same bases, which I am here, I need to add the exponent. So y squared times y becomes y cubed. So that is my second product, plus 12xy cubed. Right, so guys, what I want you to try for me is this third product. So my third product is negative 2xy squared times positive 4x. So I want you to try and get that product for me. I need to get my laptop charger. So while you're doing that, I'm going to run and grab it, but I want that product from you guys.
Let's go, my peeps. We can do this. Let's find the product. And if you got it, put it on your book and also put it on the charts. Okay. Y'all are doing amazingly well. We are learning. Oh, excuse me, sorry. We are learning, my peeps. So let's find the products. Let's find the products. Don't forget your signs. Don't forget your signs. Y'all are amazing. You're nailing this. Woo, I'm loving it. I'm loving the answers on the charts. I'm loving it, guys. You're doing awesomely, awesomely well. Okay. So is there anyone who is still confused at that answer that we are getting? Simniki, you must check your powers. So just double check your powers, and Teacher Sim is here to make corrections with us. So don't forget to correct. But majority of you got the right answer. Well done.
Okay, guys, sorry. And then I realized that my cord was too short and we had chaos. But let us do this product here for ourselves. So we have got a negative times a positive. So that's a bit different to what we were dealing with. A negative times a positive is a negative. Numbers 2 times 4 is 8. Now I need to deal with my variables. I've got an x times an x, which gives us x squared. And then we've just got our y squared by itself again. So this is just y squared. So what I want to do now is I want to go, excuse me, is I want to go and write down this final product minus 8x squared y squared. And remember, like I say, you always need to check for like terms. So our next step now is check for like terms. Hopefully what we're seeing is that we do have like terms. Remember, of course, according to our definition, like terms have the same exponent and the same variable. So all of these terms have an x and a y in them, but not all of the exponents are the same. So if we have a look at our first term, I have got an x squared y squared, and I've got a second term that is x squared y squared. That's the minus 8x squared y squared. Same variables, same exponents. The 12xy cubed also has x and y, but the exponents are different. The exponent, maybe let's not use blue. The exponent of x is 1, and the exponent of y is 3. So this makes it a completely separate term from the others. Again, if you want to reorder this to put your like terms together, you are more than welcome to. You don't have to. Personally, I don't do this, but I know for some it is easier to then add and subtract our like terms. So rather do it if it helps. And now we add and subtract. Now, in order to do this, I'm just going to draw a very rough number line because I also know that sometimes we get a bit stuck adding and subtracting values, which is fine, but we do need to start being comfortable with this because unfortunately we have moved away from this sort of basic arithmetic. And we need to be able to do addition and subtraction comfortably. So if we look at the first two terms, we've got 6x squared y squared minus 8x squared y squared. So here I am at 6x squared y squared, positive x squared y squared, 6x squared y squared, and I want to subtract 8. 1, 2, 3, 4, 5, 6, 7, 8. Can I not count? Oh, I've just missed a whole number. There we go. That's the reason.
Yes.
2, 1, 0. There we go. Okay, so there we go. I've subtracted 8, giving me minus 2. And remember, guys, when you add and subtract like terms, your exponents don't change. So this stays x squared, y squared. I will make a note on that now. And then we just write down the other term that has no like terms to it, the 12xy cubed. So I'm going to make a little note here. When we add and subtract like terms, the exponents do not change. Oh, left myself 0 space. Do not change. There we go. So that is very, very important. Hopefully what you remember is that your exponents only change if you are multiplying or dividing, and that goes back to our exponent laws. if we are adding this or subtracting like terms, the exponents stay exactly as they are. Right, so screenshot time, question time. So if anyone has any questions, now's the time to raise your hand and ask me. Otherwise, you're taking screenshots. This was quite an intense example, guys, so just take a second, make sure you understand where everything has come from, and if you don't, ask me. Otherwise, you've done very nicely, and so you're very much deserving of a brain break. Luna Fefe.
Hi, ma'am.
Hi.
So, ma'am, I wanted to ask if the negative 6xy, did it come from the expression above?
So the negative 6xy was just part of the question. So here it's just in the question. So yeah, I gave that to you.
Thanks.
Right, good, grade 8s. I'm hoping we all have our screenshots. Give me one more second. Right, let's have a look at our brain break. So what we have here is me wanting you to find the value of the expression right at the end. So it's similar to what we sort of usually do, except now we have to work along a column, along a row and down a column. Don't know what happened there. Let's maybe attempt that again. So like I said, similar to what we usually do, but we want, or I want, the value of this expression in number 1 and this expression in number 2. So you're going to have to work out the value of the snake, whale, tiger, pen, paintbrush, all of those things in order to tell me the final value. I'll just make this a touch smaller for not the brain break, but the joke. And then I will make it bigger for all of you to see again, because it's very important to see the doubles. Okay, so there was questions of when are we doing angles and geometry? We did some of that in boot camp, but that's still to come. Question of when we're doing percentages to fractions. We have actually done fractions already, so go and have a look at the videos. And yeah. So I hope we all got the joke. If not, I'll go back to just now. I just want to make this bigger so that everyone can see the doubles, when and where they exist. Suppose I need to have some answers here. Okay. Let's see. So we will eventually do geometry. We're just not there yet. Guys, remember bodmas when you are doing these. If you're not remembering bodmas, unfortunately, you're going to get it wrong. Right. I have already seen the right answer for number 1.
We can do this, guys. We can do this. Oh, I've also seen an answer for number 1, and it goes to Luno. Luno got number 1 right, my babes. Well done, Luno. Well done. Oh, Ashley got it first, actually. Now I'm going back. Woo, Teto also got it.
I think Teto was the first.
Teto, you were definitely the first to get it right, the first one. Woo,
I am going to explain it, guys. So if you don't understand where the answers came from, don't stress. I'm going to explain it. And yes, didn't we did geometry in boot camp, hence why I'm saying we still have to do it as part of our normal Watobe classes. Alrighty, guys, I do want us to be able to do a few more examples. So I'm just going to quickly go through this, but well done, all of you. I didn't see any correct answers for the last one, but I could have missed it. But for the first one, so remember, you have to read both across a row and down a column. So we know 20 plus a snake is 33. So this snake has to be worth 13. So at the bottom here, where I've got double snakes, this is 26. Now, if I work down the column, 13 times what gives me 78? 13 times 6 gives me 78. So these two tigers here are worth 6. Then you can either work down the column or across the row for the whales, doesn't matter. Easier is down because it's plus. 20 plus what gives me 42? 20 plus 22. So 2 whales is 22, which means 1 whale is 11. Now remember your bodmas. 11 times 6 is 66. 66 plus 26 is 92. So that is how we got 92 for the first one. For the second one, if we have a look here, so we know that we have the value 10. So the double pen at the top times 10 must give me 140. So these 2 pens is 14. 14 times 10 is 140. So at the bottom here, I know that's 14. If we now go across this row, what times 14 gives me 392? That would be 28. So these 2 paintbrushes is 28, which means down at the bottom, 1 paintbrush is 14. And then if I go down this column, 28 plus what gives me 38? That's nice and easy. 28 plus 10, so the 2 pins are 10. So now we've got 10 plus 14 plus 14, which gives us 38 as our final answer down here. Right, so guys, that's how we do these. Very similar to our usual brain break, just a little bit different in terms of we have to now work with going down and across and making sure that we are getting the same, or rather the correct answers. Don't stress if you made a mistake, it does happen, but just double check your operations, double check that you know what's going on, and double check that you haven't made silly mistakes. They do happen, so don't worry, but always double check yourself. Right, guys, nice. So let us have a look at another example, and this is a really nice example because, again, we always double check for our terms. Now remember, terms, we want to only consider the plus and minus signs outside the bracket. So this minus sign outside of my bracket is the only one separating terms, which means that 4 is my first term, and the whole minus xy times the bracket is my second term. Now, very importantly, we first need to simplify individual terms before we start stressing about like terms. So I first need to simplify term 1, and then I need to simplify term 2, and then I can start looking at like terms. Now, if I look at term 1, I can't do anything with 4. 4 is 4. It is what it is. So my first term is going to stay there. I'm now going to deal with my second term. Okay, now my second term involves distribution. I can see that because I've got this minus xy that I need to multiply into my bracket. So let's do our little multiplication block for ourselves. I've got negative xy. Remember, of course, there is that invisible 1 there. We just don't have to write it down. Multiplied by negative 3x. So again, do it step by step. A negative times a negative is a positive. 1 times 3 is 3. And remember your variables. X times x is x squared. Y is all by itself, so it's just 3x squared y. So we've got plus 3x squared y as my first product. Now I need to do my second product. Minus 1xy times negative 6y. Negative times a negative is a positive. 1 times 6 is 6. Remember again, variables, you've got 1x and then a y times y, which gives us y squared. So this is plus 6xy squared. Remember, of course, to double check for like terms. These are not like terms, guys. Be very careful. There are no like terms here. Yes, these last two have got an x and a y in them, but the x has a squared here, whereas this x has a 1. This y has a 1 here, whereas that y has a squared. So the exponents are not the same. And so what that means is that I do not have like terms here. Because I have no like terms, that is my final answer. Okay. At school, you were taught to use the bodmas rule. Do you mean bodmas? I'm not sure. This is technically using bodmas. I've done the multiplication first before I've done any addition and subtraction. So this is bodmas. Ma'am, don't you need to write the multiple sign because the brackets means multiple? Don't understand what that means, if I'm being honest. So, Dovo, if you can raise your hand, you can also try and explain it to me. I'm not sure. I have multiplied here. So I have done multiplication. I'm not too sure what you mean is write the multiple sign. I don't really understand. How we adding...
Yeah, sorry.
Yeah, sorry.
Nothing, someone was talking, but it's okay. I just think that I understand. I think Teacher Zev is just trying to show us how is it done with using the brackets so that you don't confuse the minus with the times there. That's why we're using them.
Yeah, so I'm using brackets in here, guys, because like Yolanda says, I always want to remind myself of what I'm multiplying and whether or not I'm double checking my signs. Ma'am, how are we adding if the expression said subtract? Well, Lawandle, remember, I've multiplied a negative and a negative. So when I multiply negatives, I get a positive. So through distribution, my signs are going to change. It's not wrong. I'm very much correct in making sure that my signs are correct. So just remember that if you've got a negative times a negative, you have a positive. And so that is why I've now got positives. Okay, someone's confused about this situation over here, so I'm going to do it again. If you look at this first product, and I hope you're all listening because I'm not explaining it again. First product, negative times a negative, like Lubanzi said there on the chat, SNV. Negative times a negative is a positive. 1 times 3 is 3. X times x is x squared. And then we just have that lonely little y there. So that is why I got positive 3x squared y. This also goes back to what I was saying now, that if you've got a negative times a negative, you will get a positive. Ovayo asked, does the brackets negative 1xy times negative 3x the same way as what you wrote? You can, it does mean the same thing. So if you just want to work with brackets and not have the multiplication there, that's absolutely fine. As long as you're multiplying, don't mind how you choose to write it down. I'm hoping that has answered all questions. I'm just going to let you take some screenshots. If there are any questions I've missed or you still need answering, please do ask on the chat, or you're welcome to raise your hand and I'll hopefully be able to explain it. The thing that was really important here, guys, is that you saw you had two terms. And so like bodmas tells us to do, if we write out bodmas for ourselves, or bedmas, whatever you want, bodmas tells us to first multiply before we add and subtract. So I first need to distribute in the second term before I start checking for like terms. Wandle, yes, terms are separated and it's specific signs. So terms are separated by plus or minus signs, which is why I said right at the start that this negative sign over here is the thing separating my terms. I don't care about the terms inside the bracket. I care about the ones outside. That negative is separating term of 4 and the term of the minus xy times the bracket. But yes, separated by terms. Motabang, yes, 4 was always a constant, but yes, in the final expression, it becomes the constant term, or is the constant term rather.